page 12 in your packet, so let's go ahead and take a look at that. The other day when we did this page, we left off the assumptions, and so that's what we're going to go over with today. So on the bottom of page 12, it has written down those assumptions. They are very different from the random, independent, and large enough, so I came up with a new mnemonic device for these linear regression t-tests, and it's line. So hopefully that will help you remember the new conditions. All right, so the first one is linearity, line and linearity. And so what do you typically check when you do linearity? Like if it's linear or not. Kind of the first thing you look at, good, is your correlation coefficient. So the first thing you generally check in the data is the R value. Good. And then you would make a statement about that. If they give you a graph, then you would reference that and say, you can also see from graph whatever that it looks pretty linear. All right, the next thing, I, is independence, and I squeezed in random on that also because I didn't want to do liner, and so I wanted it to be line. So I just kind of stuck independence and random together. And those are pretty basic statements for independent and random. They're going to be that you randomly selected from the population and that your data, one piece of data does not affect the other. So that's the independent component of it. All right, now these last two are a little bit more, are a little bit newer. In fact, the N, which stands for the normal probability plot, has to do with a graph that we haven't looked at before. So we'll go through that and we'll look at that. But basically, here's what you are saying. Is you are saying that the residuals are distributed fairly normally. So what that means is that if we had looked at this picture we did the other day, that here close to the prediction line, see, I've got more of the data close to the prediction line, and so that is 68% of the data is within one standard deviation of the prediction line, okay? And so on. And 95% of the data is within 2 standard deviations. Okay, so that's what that's going to show, and I will show you how the graph will look so that you know that is the case. All right, and the last condition is equal variance in the residual plot. And so that's messed up there. So equal variance in the residual plot is not showing up here very well. And so I think I'm just going to, okay, so equal variance in the residual plot, that means that you have a residual plot. If you were to look at a picture of the residual plot, equal variance means that the residuals are spread pretty equally on either side of this prediction line. What would be bad is if you started fanning out and at some point the data started getting farther away from the prediction line. That would mean that the data was nice and linear for a little bit and fit pretty well, but then it started getting not so good of a fit and it started getting bad, and so out here when it started getting fanning out and getting farther away, it was not a linear relationship. Okay, so with that being said, we're going to go to page 19, which is a page that has got some graphs on it. We did the panic model on it yesterday. Okay, page 19, will have some writing on it because you did the panic model yesterday for that. But we skipped the assumptions. So we did the panic model without the assumptions, and so I want to do that with you. Now, these conditions pretty much have to be shown with graphs. And in the past, I have made it such that I made the students, I gave them data and they had to make and draw the graphs. But I think on the AP test, you would if you were expected to do the conditions or make a statement about them, they would have the graphs done for you. Okay, so then you would just need to reference them. So that's how we're going to practice it today and how your homework is. All right. So let's label these graphs. Let's label this first one graph A, graph B, and graph C. Okay, so we're going to label those, and I want to take a look at what these graphs are. So graph A, if you look carefully at it, I'm not sure what it says on the x-axis. Okay, but on the y-axis, it does say residuals. Oh, it says predicted. Okay. So it says residuals. So what is missing in that picture that we normally see? A residual. Good. Normally we see this. Okay? And so what we're going to be talking about later, what we're going to say, hey, graph A shows you this. Do you see how the residuals on either side are all about the same distance apart? They don't fan out. So all of the residuals are within, the same amount apart on either side of the line. Okay? Now let's look at graph B. Graph B is, I think at the bottom, it's actually a graph of the x-axis and the y-axis. It has the education, I think it says median education, but we're going to go with education and income because that's what this problem was about. And so this one is pretty much just showing you, if I could draw it nice, that the data looks fairly linear, and it's just showing you what the data looks like straight away when you graph x against y. Okay, graph C is a kind of graph that you have not ever seen before. And so I want to tell you what it does for you. Okay, graph C at the bottom says normal scores. And on the y-axis, it says what? Residuals. Okay. So if you could see the numbers very well, here in the center is 0, and here's 0. So what that means is that this point right here, those points right there where I just drew this little green dot, where that intersects is where the data is on the prediction line. So this represents the data that is really close to the prediction line. Okay? Now, what you're supposed to notice is that if you go down one, because these are basically standard deviations. Down here, these are basically your z-scores. If you go down one standard deviation and up one standard deviation, look at what's happening in the graph. Do you see that this amount of data is more densely populated, that there's more data in that section? So this has more data because it's really probably 68% of the data is what should be within one standard deviation of the predicted. Okay? And then likewise, you will have out here 2 standard deviations out. Do you see how it gets sparse or less data points the further away you go from this middle section? Okay, so that is what this is demonstrating, is that the residuals are fairly normally distributed. So that is the new kind of graph that you've never seen before that you know how to read. Okay, so with that being done, let's go through the conditions with this, and then we'll be finished. I hope you have room on there. If not, you might have to use another piece of paper or something on your page 19. Okay, so here we go. Conditions. What's the first condition? Linearity. Good. L for linearity. All right. what am I going to reference for linearity? The correlation coefficient, which is R. Well, I look up here and I see R squared. Okay, so R is the square root of my 0.329, which is 0.574. Okay, and then you translate that. So what is the statement that I make for that right there? There is a moderate. Now, hold on a second. Do you know it's positive, and how do we know it's positive? This slope is a positive value, so that's why I knew it was positive. So there is a moderate, positive, linear relationship between education and income. Now, one of our graphs also happened to be something that I might want to reference. Which one of those might help me demonstrate linearity? Graph B. Good. So you can see graph B. Okay, that graph B is demonstrating linearity. Okay, next condition. What comes next? Good. Independent and random. Now I'm about to just write down what I would put, and it's pretty generic. It's not even in context really. So we're going to assume randomly selected, what are these people? I guess employees, is that what it says? Yep, United States employees, randomly selected employees, okay? Okay, and then we're going to assume one employee data does not affect the other employees' data. Okay, so that's pretty generic. It does have a little bit of context in there, but it's pretty much going to stay that way, and we don't reference a graph with that. Okay, so we've done L and we've done I. Next is an N, and that is the what? Normal probability plot. Okay, and what am I going to reference with that one? Okay. Yes, I'm going to say graph C shows that the residuals are fairly normally distributed around LSRL. So I'm kind of taking the shortcut. I'm going least squares regression line just because that's shorter than saying the prediction line or the line of best fits or whatever. Okay, and we're almost done. What is the last one? Okay, equal variance. Good. And so graph A shows that the residuals are equally distributed, okay? On both sides of the least squares regression line. Yay, so that's all of our conditions, so we conclude with saying linear regression T model applies. Yay. Okay, so those are the conditions. Now, let's look at what you're going to do today. If you look at the next page, page 20, you are going to create an interval, so that is a panic model. And yesterday, we skipped the assumptions because we didn't know them yet, but now we know them, so now you can do them. Yay! Okay, I do want to show you one other thing, though, and that is on page 21. Yes. Okay. So on page 21, let's just kind of look real quickly. What condition is you're gonna reference A for? It is a graph of x against y. Linearity, good. So A will be used for linearity. B, let's go to C. C is the residual plot, so C will be referenced for what? The equal variance in the residual plot, equal variance. B is another way to show that the residuals are fairly normally distributed. Residuals are fairly, so this one will be used for which condition? The normal probability plot. Good. And see, here's why. Do you see this residual of 0? Well, here are all the items that have a residual of 0. And then here's all the items that have a residual of 7.5. And then so on. And so as you get farther away, what's happening to the number of pieces of data that are that far away? You're getting less and less. Good. So as we get farther away, we're having less data items. That's because the residuals are fairly normally distributed about the least squares regression line. Okay, so I want you to just do pages 20, 21, and 22. I will allow you to omit page 23, but don't just cross it out. We may need it and do some of it or use it for something later. So go ahead and just put omit on page 23 and do your 20 through 22. No,